We started our company to accelerate software. Our vision was,
why did NVIDIA start in the first place? What was their mission? And how did they come up with the revolutionary idea of accelerated computing? Have you ever wondered how technologies like real-time 3D graphics and AI-powered solutions became a reality? And what exactly is CUDA, this groundbreaking invention that changed the way industries solve complex problems? From the smallest details of computer graphics to solving massive global challenges in AI, healthcare, and even quantum computing, NVIDIA has been at the heart of innovation for decades. But how did it all begin? And what's the secret behind their unmatched success? Stay with us as we unravel the fascinating journey of NVIDIA, their vision for the future, and how they turned impossibilities into game-changing realities from its CEO.
we started our company to accelerate software. Our vision was, would benefit from acceleration if we augmented general purpose computing. We take the workload that is very compute intensive and we offload it and we accelerate it using a model we call CUDA, a programming model that we invented called CUDA that made it possible for us to accelerate applications tremendously. That acceleration benefit has the same qualities as Moore's Law. For applications that were impossible or impractical to perform using general purpose computing, we have the benefits of accelerated computing to realize that capability. For example, computer graphics. Real-time computer graphics was made possible because of NVIDIA coming into the world and make possible this new processor we call GPUs. The GPU was really the first accelerated computing architecture running CUDA, running computer graphics, a perfect example. We democratized computer graphics as we know it. 3D graphics is now literally everywhere. It could be used as a medium for almost any application. But we felt that long-term, accelerated computing could be far, far more impactful. And so over the last 30 years, we've been on a journey to accelerate one domain of application after another. The reason why this has taken so long is simply because of this. There is no such magical processor that can accelerate everything in the world. Because if you could do that, you would just call it a CPU. You need to reinvent the computing stack from the algorithms to the architecture underneath and connect it to applications on top. In one domain after another domain, computer graphics is a beginning, but we've taken this architecture, CUDA architecture, from one industry after another industry after another industry. Today, we accelerate so many important industries. CULitho is fundamental to semiconductor manufacturing, computational lithography, simulation, computer-aided engineering, even 5G radios that we've recently announced partnerships with, that we can accelerate the 5G software stack, quantum computing, so that we can invent the future of computing with classical quantum hybrid computing. Parabricks, our gene sequencing software stack. QVS, one of the most important things every single company is working on, is going from databases to knowledge bases so that we can create AI databases. Using QVS, we can create and vectorize all of your data. QDF, data frames. Data frames is essentially another word for structured data. SQL acceleration is possible with QDF. In each one of these different libraries, we're able to accelerate the application 20, 30, 50 times. Of course, it takes a rewrite of software, which is the reason why it's taken so long. In each one of these domains, we've had to work with the industry, work with our ecosystem, software developers and customers, in order to accelerate those applications for their domains. cuOpt, one of my favorites, combinatorial computing application. A very compute-intensive application, for example, the travel salesperson problem. Every supply chain, every driver-rider combination, those applications could be accelerated with cuOpt. Incredible speed up. Modulus, teaching an AI the laws of physics. Not just to be able to predict next word, but to be able to predict the next moment in time of fluid dynamics and particle physics and so on and so forth. And of course, one of the most famous application libraries we've ever created called cuDNN made it possible to democratize artificial intelligence as we know it. These acceleration libraries now cover so many different domains that it appears that accelerated computing is used everywhere. But that's simply because we've applied this architecture, one domain after another domain, that we've covered just about every single industry. Now, accelerated computing, or CUDA, has reached the tipping point. Several years ago, about a decade ago, something very important happened. And most of you have seen the same thing. AlexNet made a gigantic leap in the performance of computer vision. Computer vision is a very important field of artificial intelligence. AlexNet surprised the world with how much of a leap that it was able to produce. We had the benefit of taking a step back and asking ourselves, what are we witnessing? Why is AlexNet so effective? How far can it scale? What else can we do with this approach called deep learning? And if we were to find ways to apply deep learning to other problems, how does it affect the computer industry? And if we wanted to do that, if we believe in that future and we're excited about what deep learning can do, how would we change every single layer of the computing stack so that we could reinvent computing altogether?